Namaskar, my dear friends. Let us talk about a circuit design for BLDC motor driver application. So this is the particular IC that we have taken from Microsystem, ALLEGRO Microsystem. So what we will do is we will try to understand what is this particular IC and how it is going to drive my motor driver applications, each one of them one by one. Alright, so we have the ALLEGRO Microsystem, one of the IC that we have taken. The device name is A89301. And this is the IC that is going to have the capability of ultra quiet and code free. There is no need to have much of the code that is needed, and this is a sensor less BLDC motor controller. Okay, so there is no sensor, hall sensor or something needed for that. And why we have chosen this particular IC is this is very good IC for the applications of, let us say, ceiling fan, table fans, then pedestal fan. We have bathroom exhaust or kitchen exhaust, like kitchen exhaust fans are there. Then we have home appliances and pumps. So these are the several applications that this particular IC can be used for. So if you see quickly the block diagram, what we have done is we have the motor driver IC, we have the MOSFET circuit, to drive for each of the lines, like gate high driver, gate low driver, everything. And then we have the BLDC motor. We have used one motor microcontroller. So this microcontroller can be used for various applications. So we have used a low cost microcontroller from Texas Instruments. All right, so let us get into the circuit and try to understand what are the different parts or different sections that is there. So as you can see, this is the particular IC that I have been talking about. So this is the power supply pin VBB. Then we have charge pump. Then we have CP1, CP2 charge pump pins. Then we have one regulator output. This regulator output can give you, around 2.8 volt. Up maximum it can give you 4 volt. So basically 2.8 volt or 3 volt is the nominal voltage value that can be used. So this is the particular voltage that can be used for driving your microcontroller also directly. So it is a very low cost design. And the maximum current that you can draw is 10 milliamperes. So you have to make sure your current consumption from this particular voltage regulator is less than 10 milliamps. Okay, so my microcontroller will be taking less than that. We have power supply connector here. So we will be needing one VM supply that will be, let us say, 12 volt or even 24 volt. It can take up, not a problem. But this particular IC is capable of taking up to 50 volts input. Okay, but our design is let us say 12 volt or 15 volt or even 24 volt. Nominal is fine. Coming back to the other parts, so these are GHA and GLA, that is high side gate driver and low side gate driver. So you can see this is my GHA and this is my GLA. So high side MOSFET and low side MOSFET. So 3 pairs are there, 1 pair, 2 pair and 3 pair. And this is my motor driver or motor connector for all the ABC pin, that is UVW phases. So SA, SB, SC are the output of the motor control. Okay. And GHA and GLA is high side and low side driver, and SA, SB, SC are the motor driver control. Okay. Coming back to the controls, current sense pin. So this is my current sense pin. You can see SN, SCNP and SCNL, SCNN. So this SCNP and SCNN. So from between these two, this is my current sense resistor. So between these two pins, this is directly connected, as you can see. So this is also grounded, this is also grounded. So this is how you are going to sense the current sensing. Okay, coming back to the other parts, we have speed controller. So this is my SPD pin. So speed controller can be by either you can put a PWM signal there, or otherwise you can put an analog voltage, okay, or even a clock signal you can give there. Okay. So in this particular board, what I have done is this particular SPD pin can be driven by this particular potentiometer. So as my resistance varies, the speed of this particular a driver will be varied. Similar to that, this SPD pin is also connected to my microcontroller PWM. So you don't need to use this particular potentiometer. and you will be able to control through the PWM. Okay, so that is done. Coming back to the direction pin, so direction can be two side, either it can be ABC or ACB, so forward direction or reverse direction. Okay, so this direction pin, if it is high, it will be ABC, so I have pulled it up permanently, so it will be forward direction. If you want to make it like reverse direction, you can you can use this resistor to pull it down and you make it not used. Okay, so like that you will be able to use ACB. At the same time, this direction pin is connected to microcontroller also, so there also you can have a control. Similar to that, we have brake pin. So brake pin will help you to like put a brake on the motor driver output. So in that case, this brake will be working like this. So if it is like low, brake is not applied. If it is high, brake will be applied. So that you have to take care of. This particular pin is connected to my microcontroller also, so microcontroller will be like having a control on this particular pin. Coming back to the fault indication, so this fault indication is open drain type output. So this is output pin. So what happens is, let us say this is high, so it means there is no like a fault in this particular IC. If it goes low, then this will be a faulty condition. So what will happen is this particular LED will start glowing. So I have connected this particular like LED through this particular resistor, so that whenever there will be a fault, it will become 0, and this is how it will be start glowing. So this was complete circuit for this particular motor driver circuit. As you can see in the control side, we have 6 MOSFETs that we have used, and this particular MOSFET is having good capability like 100 volt and 50 ampere around for like drain to source current. And this particular like connector has been used to give you the motor supply, motor connection at this particular place. Let us get into the microcontroller section. So if you come to microcontroller section, this is the particular microcontroller that has been used. So you can see fault pin is there, brake pin output is there, direction pin output is there. Then we have SPD, one more PWM is there. Okay, so this much only 4 pin is needed for complete application that is there. One more FG pin is there. So FG pin I have added to I2C pin, so that if you want, you can use I2C functionality as well. Okay, because FG pin is having the capability of I2C communication. Rest other pins are there. This particular like connector is used to have external communications. If you want, you can use external board and drive them. You have UART communication, you have ADC values, all those things can be done. That is not a part of this particular project, but it can be used. Okay, similar to that is this particular microcontroller can be also powered through this VREG itself. So I have put 0 ohm resistor here, and then this will be powering up through this. Okay, and this particular microcontroller can be programmed through this particular connector. So this particular connector will help you to have SWDIO and SWCLK, and similar to that we have a reset switch that is also connected. So if you do not want to use reset functionality, you can remove this and you just have to keep it always pulled high. Okay, so this was all about this particular circuit. If you want to use have other functionalities, I have added 2 extra LEDs. So user LED 0, user LED 1, for various functionality you can use them. Then we have 2 push buttons, so this also you can utilize them for various applications. And then we have used one linear regulator for converting directly VM voltage that is coming to a supply, let's say 12 volt or 24 volt. So this can be converted to 3.3 volt, and this can be used to supply the microcontroller, and this resistor you have to remove. Okay, so this is how for high current application you can use this particular regulator. Now let me tell you what are the different things that you can remove, so that you can have a minimal circuit and complete your like complete circuit. Okay, so in that case what you have to do is, let me tell you I will use this particular color to put a cross mark on that. So you don't have to use this one. So this regulator's complete circuit you can remove. These 2 LEDs you can remove. These 2 like push buttons you can remove. Then this particular external connector also you can remove. Even this UART signals and all you can remove. Okay, so this one you can discard off. Even this I2C, if you want, you can remove, or otherwise let it be. Okay, so this much, the remaining ones you can use this. Coming back to this place, you don't have to use, like this particular potentiometer. The PWM will be able to take care of that, and you don't have to use, or otherwise everything is fine, fault, break, you have SPD controller, like speed controller, direction, you have FG pin, everything is fine. If you want, you can reduce a little bit of, like I mean, this particular capacitors. So this capacitors, if you want, you can reduce one of them, you can like remove, like let's say this and this you can remove. Rest others you can keep it as it is. So hope you have a very good understanding of how to design a very simple motor controller or motor driver circuit for various applications like ceiling fans, or like exhaust fans in your kitchen or bathrooms, and various other home appliances wherever there is a need of code free, like design for motor control driver. So if you do have any questions or any understanding that is needed for small applications, you can put down your queries or questions in the comment box, and we shall be able to reach you out. Or otherwise, if you want to hire something for your design purposes and all, you can always reach to our contacts that is given in the like in our description, and we will be able to support you in any situations. Thank you.